Okay, good morning class. In this last video of the course, we're going to look at a method for adding vectors. And in the method I present, I'm going to be using two main parts. One is resolving the vector into its components. So that means taking this vector here are situated at an angle of theta and writing down how much of it acts in the horizontal direction, that will be Rx, and how much is acting vertically, and that will be Ry. And because of the trigonometry involved, it is true that Rx is R cos theta. That's the horizontal component. And the vertical component is R times the sine of theta. So when we go to add our vectors, we will first resolve them into these horizontal and vertical components. Then, once we have those horizontal and vertical components, we will take their sums. And then we will find out the resultant of that total horizontal and vertical component. Once again, using right triangle trigonometry, you will find that the resultant, since it's the hypotenuse of a right triangle, is found by using the Pythagorean theorem. So r will be the square root of rx squared plus ry squared. And the angle theta will be found by recognizing that it's the tangent inverse. Here I've got arctangent written, but it means the same thing as tangent inverse of ry over rx. So I'm going to go through this process with you now with 3 examples. When we're in quadrant 1, we'll have to make no adjustment at all to this angle. However, in the other quadrants, we will use this chart. You might remember this from our trigonometry unit, whereby the angle in quadrant 2 will be 180 minus. In quadrant 3, we'll use 180 plus, and in quadrant 4, 360 minus. Okay. So let's get started with a first example. So it says, add the vectors. We have 422 at 0 degrees, 210 at 110 degrees, and 405 at 235 degrees. Each side length has been written with 3 significant digits. That's why we have this little bar over the 0 here. And each angle with 1 decimal place. So I've tried to draw this for you here. So 422 at 0 degrees would be this line pointing to the right. This much shorter line of length 210 is at 110 degrees. So from the positive x direction, moving around 110 degrees counterclockwise and drawing that line. And the last line should be almost as long as the first one. The length is 405 and at an angle of 235. So from the positive x direction, moving around counterclockwise 235 degrees. So this isn't completely to scale, but it gives you an idea. And you can picture these as 3 forces perhaps acting on this object. And we want to know what the overall result would be. So here's how we start. We calculate Rx and Ry. And when calculating Rx, you use cosine. So 422 cosine of 0 plus 210 cosine of 110 degrees plus 405 cosine of 235 degrees. Okay, and we're going to get our value for that. And then we change these things to sine. in order to determine the vertical component. Okay, so here we go. I'm going to punch this in with you. So 422 cos 0 plus 210. Oh, I think I'm in radians. Sorry. Good point. Everybody check. Make sure you're in degrees. Okay, when you're in degrees, there'll be a little D on your display. 422 cos 0 plus 210 cos 110 plus 405 cos 235, and I get this. Okay, and I'm gonna round my final R value to 3 significant digits. So for now, I'm gonna keep extra. So I will keep 4 significant digits. So that's 117.9. Okay, clear. Now we're gonna, oh, I could have just gone back in and changed them to sine. But anyway, 422 sine 0 plus 210 sine 110 plus 405 sine 235. And that is the vertical component of the total force, negative 134.4. Okay? And do you understand why we use cosine for horizontal and sine for vertical? If you picture a right triangle here, then Rx is the adjacent side. So the cosine of theta is adjacent over hypotenuse, and that's why we use R cos theta for Rx. And if you're finding Ry, and this is the triangle here, then Ry is this vertical side, okay? And it's therefore opposite the angle. So we have the sine of theta is Ry over R, and Ry then is R sine theta. So it's always cosine for horizontal component, sine for vertical component. Okay, now, before continuing, we need to draw a picture for this. So this is important. In fact, I don't care if you draw the beginning picture at all. You can just start your question with the calculation of Rx and Ry. But this next part is important. A positive horizontal component, what does that mean? The horizontal component points right or left. So a positive horizontal component points to the right. What does this mean? A negative vertical component. The vertical component points up or down. So a negative vertical component points down. So let's just draw this scenario. So from a point, we need one line pointing to the right. And then a line that's a little bit longer, because this number has a bigger magnitude than this one. So a little bit longer, pointing down. Now, we no longer include any negative signs here. We're using magnitudes only. So that's 117.9. This length is 134.4, like this. And so, where will the resultant be? Well, you make a rectangle like this now. Okay, sorry. Primitive picture. Okay, and then draw your vector. That's the overall resultant. And so what we're gonna do is work out that length R and that angle alpha. So to work out R, we remember that we could use this right triangle here. This side is 117.9. This side is 134.4. So R is the hypotenuse. So we simply can do R is the square root of 117.9 squared plus 134.4 squared. Okay, so we'll do that with our calculator. Oops. And then this is now a final value. So, and it's a side length. So it should be rounded to 3 significant digits. So let's try that. I'm just gonna do 117.9 squared plus 134.4 squared is equal to this number. Take the square root and I'm gonna have 179. Okay, so we're gonna use 179 as our answer for R. So if these were all forces in newtons, this would be 179 newtons, for example. Okay, now what about working out alpha? You can always use tangent inverse or arctangent, as it says on the formula page. That means the same thing, okay? So arctangent of what? You want to make sure you put opposite over adjacent. So opposite is always going to be this one, the vertical one. So always the RY value and the RX value. But again, once you draw the diagram, you no longer include any negative signs because the negative is indicated by the direction. So we don't want any negatives in these calculations at all, okay? All right, so here we go, and I'm gonna round the angle to the 10th. So we're just gonna do shift tangent, and then it's 134.4 over 117.9. You can see that's 48.7 degrees. Okay, but that's this triangle here, this angle here inside my little triangle. And I want to always have my angles in standard form, which means start at the positive X direction, move around counterclockwise until you hit the line called R. So that's going to be theta. So in this case, it means 360 degrees minus alpha. Okay, so if we take 360 and subtract 48.7 from it, we will get 311.3 degrees. This, of course, is quadrant 4. Remember how the quadrants go? I think you guys do. 1, 2, 3, 4, right? And here, when you go to the right and down, so from here to the right and down, your resultant is definitely in quadrant 4. So I might just indicate that here as a little reminder to you. See, this way it's consistent with your chart as well, 360 minus alpha. Okay, so then how would you write your final answer? You just want to make it look something like this. So you would write the final answer is 179 with an angle of 311.3 degrees. Okay, so that is the final answer for our first example. But I'd like to do a couple others with you as well. Okay, so let's try a second one. We're gonna add 2 vectors this time, 40 at 125 and 60 at 200 degrees. So the side lengths will be 2 significant digits and the angles will be just to the nearest degree. So I tried to draw this. Here's the positive X direction. So if you turn up 125 degrees, this is the side length 40. And then again, starting from that same positive X direction and moving around 200 degrees, the longer line here is length 60. So we want to know what's the sum of those 2 vectors. So we do it the same way, Rx and Ry. So let's use cosine first. So 40 cos 125 plus 60 cos 200 equals, and then we just change that to sine in order to get the vertical component. So clear. 40 cos 125 plus 60 sine 200 is, okay, so there's my first quantity. Doesn't match what I have on my paper, so that's weird. What did I type in wrong? Oh yeah, I put sine, look at that. Okay, let me do that again, okay? 40 cos 125 plus 60 cos 200. Okay, that's better. So that's Rx, negative 79.32. I'm going to be rounding to 2 significant digits, so I just want to keep a little more for now because this is not a final answer. Now, if I change those both to sine, I will have Ry. I think you can do it like this. So that one is sine, and then back up to this one is sine. So now they're both sine. Push equals 12.24. Okay, that just saved me from having to clear it and type it in again. Now we're about to draw a diagram. So how should we draw it? One line pointing to the left. A negative Rx value means left, because Rx is the left or right guy. A positive Ry value means up, because Ry, being the vertical component, is the up or the down quantity. So I need a long line to the left, a short line up. Okay, so I'm going to do that. I'm going to say, that's my short line, 12.24 up. And from that same spot, I want a longer line, okay, to the left. So now you should be able to see that this is quadrant 2. The origin is here. So up and to the left, you're going to have a resultant in quadrant 2. So how will the resultant be formed? You make a rectangle like that. Okay, and then from the origin to the end there, like this, that's your R. Oh, I didn't even talk enough about how to correctly locate your alpha now, because there's 2 possibilities. Is alpha this lower one, or is alpha this upper one? And back here we had 2 choices as well. Was it this upper one, or was it this lower one? So that's my fault for not clarifying. When you draw alpha, you must make sure it touches the horizontal axis. Okay, so that's how I knew alpha had to be up here. And in this case, this is the horizontal axis. So that's how I know alpha is down here. Okay, so we can make our calculation now for R. So using the Pythagorean theorem, we're going to do the square root of 12.24 squared plus 79.32 squared. That looks like degrees. Okay. So we're going to work that out first with our calculator. So 12.24 squared plus 79.32 squared. Take the square root, and we're going to round to 2 digits. So it's 80. We need a little bar, okay, to show 2 significant digits. Now we're going to work out alpha. Notice I have no negative numbers beyond this point. After you do Rx and Ry, you will have no negative quantities. Okay, tangent inverse, and it's always the vertical one because it's opposite over adjacent tangent. So opposite, 12.24 over adjacent, 79.32. The angle should be rounded to the nearest degree. Okay, so 9 degrees. However, we had already noted that we are in quadrant 2 because we went from the origin to the left and up, right? From the origin, we went to the left and up, which makes our resultant in quadrant 2. So how is theta found in quadrant 2? Well, the chart tells you it's 180 degrees minus alpha. But this diagram would tell you that as well, because theta should be measured from the positive x direction. You simply move around counterclockwise until you hit the line called R. So that's theta. So that's a straight line. That's 180 degrees. And that's why theta is 180 minus alpha in this quadrant. So 180 minus 9 degrees is 171 degrees. And so the final answer for this problem is 80 at 171 degrees. Okay, we'll do one last problem together with the exact same number of steps. So again, I don't care if you start with this kind of picture at all. You don't have to. But anyway, here's 20 at 170. So positive x direction. I turned around this way 170 degrees. So almost forming a straight line. And I drew the line 20 units long. And then 245 degrees from the positive x direction is here. And I drew the line 70 in length. So here we go. Same deal. Rx equals Ry equals. Okay, so we're going to use cosine for Rx. So 20 cos 170 plus 70 cos 245 equals, okay, so negative 49.28-ish. Okay, and now if I do sine in place of cosine, so here, and here. Okay, now I have Ry, so negative 59.97. Let's assign direction to these things. A negative horizontal component is a line pointing to the left. A negative vertical component is a line pointing down. So I'm going to draw that. So I need a line pointing left, and that length right there I'm going to call 49.28. And from that same spot, a little bit longer of a line pointing, a little bit longer of a line pointing down. So obviously I'm not drawing it to scale, but okay, 59.97, 49.28, just like that. And from there, now you know how to draw the resultant. Make your box. that's your R, like that. Where's your alpha? Up here or down here? It has to touch the horizontal axis, which makes it here. Okay, what quadrant are we in if we've gone to the left and down? Right, so we started at the origin, we went to the left and down. So we are surrounding quadrant 3. Okay, let's figure out R. Just use the Pythagorean theorem. So R squared is equal to this. And let's work out R. So we do 49.28 squared plus 59.97 squared equals square root. I'm going to round to 2 significant digits, so that's 78. So that's the length of the line. Work out, and it's the hypotenuse of the triangle here, right? Because this is 49.28. This over here is also 59.97. So this is definitely the hypotenuse. The right angle would be here. Let's work out alpha. Tangent inverse of 59.97 would be opposite alpha, and adjacent to alpha is 49.28. Okay? Tangent inverse 59.97 over 49.28. So that's my angle. I'm going to go to the nearest degree. So 51 degrees. And then, as we already noted, we happen to be in quadrant 3, where theta is found by doing 180 plus alpha. So 180 plus 51 degrees is 231 degrees. And of course, the diagram is consistent with that. From the positive x direction, go around until you hit the line called R. One straight line plus alpha more in order to obtain theta. So you can do it all with the picture, or you can use the chart here. Okay, so we're all set. Final answer would be written like this: 78 at 231 degrees, just like that. So please take the time to try the problems. Notice I did not do an example that ended up with the resultant in quadrant 1. That would be the most simple scenario, because after you obtain alpha, you would be done. You would not have to adjust the angle at all if you had a resultant in quadrant 1. When you do this question for me on the test, I absolutely want you to do it like this. Figure out Rx, Ry. Then, beyond that, there should be no negative signs. And I absolutely need you to draw a diagram, just like I've done in all 3 examples. Okay, thanks a lot. And guess what? You just got through your last video lesson for the course. Time to celebrate, I'm sure. Okay, take care, and please try the suggested homework problems.